This is a demonstration of the autopilot final prototype designed in Tinkercad. It consists of an Arduino, two ultrasonic sensors, two motors, the multiplexer, and two LEDs. The ultrasonic sensors and the LEDs are connected, and the multiplexer are all connected to numbered pins in the Arduino, and both the motors are all connected to multiplexer pins here. All the components apart from the ultrasonic sensors are all connected with 560 ohm resistors. This is the Arduino code here. All the variables are defined at the start of the program. These are the pins for the multiplexer. These are the pins for the sensors. They're trigger and echo pins. These ones here. And these are the LED pins. These variables will be used to capture the distance from both the sensors, and because the multiplexer works in 8 bits, the outputs that will be sent to which output has to be powered has to be sent through byte values. In the setup function, the serial monitor is started and all the pins are set up. Most of these are output pins, however the echo pins for the sensors are counted as input pins. Moving on to the loop function, first the program will find the distance from both the right and left sensors. This is done by sending a signal through the trigger pin, and it will wait a small amount, then it will obtain this distance using the echo pin and read that distance, storing it in the distance float variable. This is then calculated and converted into centimeters using this equation here. Then the distance is then printed into the serial monitor and returned for the function. Going back to the program, it will then use these distances to calculate if something is close to them. If an object is detected in both the sensors within 20 centimeters, both these LEDs will turn on, the motors will stop, the program will wait a second, the motors will then reverse, the program will wait 1 second, and then just the right motor will be turned on. These functions are all defined here. The move forward function will update the shift register to power outputs 8 and output 5. The reason these are 0 and 3 is because the pins are read in reverse. The serial monitor will also receive a moving forward message. The stop function will send no power to any of the pins, so none of the motors will move, and it will print stopping into the serial monitor. The turn left function will update the shift register by powering the left motor, and it will power the right motor but in reverse. It will update the shift register and print turning left into the serial monitor. The turn right function will also do the same thing, just for the right motor, updating the shift register and printing turning right. The reverse function will power pins 7 and pins 4, updating the shift register with these pins so they are powered, and essentially reversing the power of the circuit so that the motors will power. And update shift register function will take that output in a value of a byte and essentially just power whichever pin is sent, or no pins if a 0 is sent. Going back to the loop, if there is something detected but only in one, or if there is nothing detected, it will go down. If something's detected in just one of these, either the left or the right, it will turn the respective LED on. If something's detected in the left, it will turn the left on, and it will make the right motor move. The same goes for the right one. If something's detected there, it will turn the left the right motor on, the light bright LED on, and turn the left motor. After this, it will wait for half a second and loop back to the beginning. If nothing is detected in both sensors, the move forward function is run, which just moves both motors forward, and any LEDs are reset and turned off. So if I run this code now, as you can see, let me just move the objects far away. So as you can see, there's no object, and the distance is seen there, about 105 and 138. Yeah, that seems right. And as you can see, the motors are all moving forward. If I decide to move just this one down, as you can see, this LED turns on. This one will be moving in reverse, and this motor will be moving, just this motor will be moving forward. If I move this back and just do this one, as you can see, the opposite happens, where this now goes in reverse, and this will happen in just this one will move forward. If now both of these are going, both the LEDs will turn on, it will stop, it will stop, and both motors will now be in reverse until the object is moved. So once the object goes away, the motors both move forward again. As you see, everything is printed in the serial monitor so that they can be evaluated and tested. That is all. See you later.